Test one, two, three. How about now? Ah, there we go. There we go. As I was explaining to the chat, which was silent at the moment, it's been a while since COVID when I got used to doing all of this remotely. So, all right, now let's get started for real. So, hello everyone. My name is Nathan. I am one of the presenters for today. Welcome to the 2023 Arizona VRC Team Workshop. Thank you for your flexibility in terms of being able to attend remotely rather than in person. Obviously, it would have been preferable if we could have done in person, but hopefully the knowledge will be useful nonetheless. Okay, so third time's a charm. So, some notes about the workshop for today. There is going to be a lot of information presented. Don't worry, a recording of these presentations will be made available after the fact. There will also be slides available. They will be sent out to you via email, and we'll also put it on the robot events page so you can reference those slides. There are some embedded links in these slides so that way you can reference things later on. In terms of asking questions today, you have a couple of options. You can ask in either the YouTube chat or you can use onlinequestions.org. I sent that link to all registered participants. Enter in the room number, and then that's a way that you can ask questions without having a Google account. It also allows you to upvote questions and make comments as well. So whenever you want to provide feedback to the presenters, whether it be a question, comment, whatever, feel free to post it in either method. I can see both of them on the screen in front of me. That being said, the agenda for today, first we're going to start with designing a competitive robot. We'll jump into judging and engineering notebooks. At the same time that the judging and engineering notebooks presentation starts simultaneously in the second room, we will have Carter talking about best practices at competition. We'll break for lunch, come back, and then in the primary room, Charles will talk about intro to sensors and controls, as well as intro to programming. And then in the secondary room, right after lunch, Grant and Benji will talk about robot building tips. So that's our general plan for today. This applies to my presentations, but I'm sure to all the other presenters as well. Please ask as many questions as possible. It's very easy to get them queued up nicely in the chat. The presenters will let you know if they plan on addressing that question in their presentation or just answering it as is. We've built in some time in the presentations to ask questions, so if you don't ask any questions, they might end a little early. So ask questions so that way you can get as much knowledge out of us as possible. All right. That being said, let's go ahead and talk about designing a competitive robot. So, good morning. Once again, my name is Nathan. In case you don't know who I am primarily nowadays a certified head referee for VRC. So, you usually see me looking like on the right in a referee jersey, hopefully with less stream again this season. And I'm also an event partner for the one of the event planners, I should say, for the Arizona State Championships here. I'm also a board member for 18 by 18 AZ, which is a nonprofit that helps support VRC events locally here in the Valley. And then before I was volunteering, I started a VRC team, 8800X, the Phoenix Lights. I was in high school for a couple of years with that. The most notable accomplishments they had were winning the state championship 3 times, as well as winning the State Excellence Award 3 times. And then in university, I was on VexU Pyro for 3 seasons. Kind of gives you a background of me. And then just an agenda for this particular presentation. So we're going to go over strategic design. That entails breaking down the game, brainstorming ideas, researching designs, prototyping, ultimately consolidating all that information to actually design the robot. And then we'll go a little bit over team structure as well, since that all kind of ties in together. Okay, let's get into the meat and potatoes of it all. So, the question that should guide your team through the entire season: what do we want to achieve? Now, this is important because different goals are going to require different levels of resources. A team who sets their goal as winning the world championship is going to require very, very different resources from a brand new team who's just trying to win a local qualifying event. It's going to require a different amount of time, a different amount of money, and a different amount of experience. So it's important to make sure that your goals are realistic. That's not to say don't be ambitious. You should still make a goal, something that you want to achieve and something that you work towards. But you just want to be a bit realistic in your expectations. And to give you one concrete example, the very, very first season, I started a VEX team with some of my friends. I was a junior in high school, and we had prior robotics experience, but not prior experience in VEX. So our goal was to qualify for the state championship. we were successful in doing so. We won all 3 of the qualifying events we went to, and we actually ended up being state finalists that year. It was quite fun. So we're really high. We got to attend the world championship. Didn't ultimately make the elimination tournament, but we were just there for fun. So naturally, the next season, we set our goal as, well, we're going to win the world championship, even though we had never been to the elimination tournament at Worlds before within our division. I'm going to give you a guess on how that went. Not so well. Now, a more realistic goal for us maybe would have been to simply make it to the elimination tournament or make it to division finals, perhaps. But remember, only 2 teams are going to win Worlds. And obviously, everyone wants to win Worlds, but there's only going to be 2 teams. So make sure you're setting a goal that's within the resources of your team. If you're a newer team, you haven't done any robotics before, winning a local qualifying event or qualifying for the state championship is an awesome goal because it is difficult to do that. If you're making a second or third year team, maybe your goal is winning the state championship. If you have prior robotics experience in other programs and you're starting a VEX team, it just really depends. Work within your team, talk to your team members, figure out how much time, money, and resources that's going to require to get to those goals. Now, kind of related to that, I want to throw this out to the chat real quick. Why are the top teams successful? So this is speaking like the top teams in the state, top teams in the world. What differentiates them? Go ahead and put that into the chat or on the online questions if you can. And then there's going to be a bit of a delay, so I'm going to awkwardly sit here for a few seconds while I wait for responses. I think the stream delay was about 20 or 30 seconds from when we timed it. So, and if I don't get, so. Okay, I think we'll go ahead and move on here. Not seeing anything in chat at the moment. Again, it's difficult to gauge with a delay, but here's some reasons why. So, competitive teams are going to set high goals and they're going to learn a lot in the process. So, a team that says, I want to win the state championship, they're going to have to dedicate a lot of resources. Okay, we just got a response. So, I know the delay's a bit longer than I expected. How they build their robot and how they use it. That's true, yes. So, and that's going to come from their prior experience. So, with teams that set high goals, they're going to learn a lot in the process. Oftentimes, well, not oftentimes, very much the case, the top teams are putting a lot of hours into the program. High interest. Here we go. Another response. High interest, engagement, Vex forums, Discord, iterative designs. Yes, perfect. So engagement in the community. So collecting information from other teams and just generally being very plugged into everything. And that's excellent. That's part of putting hours into the program. Okay, I think we got a couple there. So top teams also, generally speaking, and this is not a hard set rule, this is just generally my observation from what I've seen, from students going from no robotics experience, I would say it takes approximately 3 years for them to become highly competitive in whatever program they are in. So if they have prior experience in a different program and they're transferring it, they could be successful almost immediately. But if they're starting from nothing, generally, from what I've seen, it takes about 3 years. And again, sometimes some wonder teams come out of nowhere and you're like, holy cow, that they're just all of a sudden good. So not saying it can't happen, but that's generally what I've seen. Another interesting aspect is that starting fresh with new students is going to erase all the knowledge on your team. So one thing I highly recommend doing, if it's possible to structure your team this way, is to always have overlap between your 2 teams or on your team itself. So if you have 2 or 3 seniors that are going to be graduating, try to have 2 or 3 freshman students who are also going to be on the same team and learning together. So that way, when the seniors graduate, the freshmen have been working with the seniors, and all of that colloquial knowledge that the seniors have collected over the number of years gets passed down, and you aren't starting from nothing. And then part of that is just creating a culture of sharing and teaching. So you can have seniors and freshmen on the same team, but if the seniors ultimately aren't being cooperative and aren't actively working with the freshmen, it's not going to do anything. So you also need to create a team culture of actually being collaborative and supporting the younger students itself. It's not just enough to have them on the same team. And then another really, really important thing is to not complain about the good teams winning. Instead, you want to ask yourself, what makes those teams successful and how can I emulate them? It's very easy, and I fell into this exact same trap when I was a very young competitor in middle school. Was, oh man, those top teams, they're just so good. I don't like them. They have no lives. Not true at all. Those top teams, they have lives outside of robotics. They put a lot of time and effort into the program. And if you emulate what they're doing, you can find that you can be just like them. It just takes channeling that negative energy towards something productive. Okay, for newer teams, if you are a newer team that's listening, in terms of ways you can kind of help jumpstart your experience, definitely network with more experienced teams. You can do that through online groups, at events, at scrimmages. There's Discord groups. Just got to be careful, of course, making sure you join properly moderated ones. And so just getting out there and talking to people who already have the experience. If you're a coach, networking with other coaches in the area, figuring out how you do this whole robotics thing, because it's a lot at once. If you're completely new to robotics, it's going to hit you like a brick wall. It's a lot of information. Something that's very, very helpful as a resource is the REC's Foundation knowledge base articles. There are a lot of useful resources on articles from ranging from robot design, organizing your team, how judging works. There are so many excellent articles on there. I've got a link to it on these presentation slides that you can get to after the presentation is over. You can also just search it on Google as well to get to it. Highly recommend digging through those. I remember my very first year in VEX, I was just constantly chugging through the VEX forum and whatever online YouTube videos I could watch to just gain knowledge. That's definitely required. Well, not required, but it's definitely extremely helpful in terms of jumpstarting your experience. Okay, now let's actually jump into the designing your robot. So, before you design anything, remind yourself of your goals. Ultimately, you're going to design your robot around your game strategy. And the strategy that you play is going to be based on your team's limits and resources. So, we'll find out what that means exactly in a bit. But before you do absolutely anything, please, 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 please read the game manual. You don't just start playing some random board game like, we'll just figure it out as we go along. Who needs to read the instruction booklet? The rules are what make the game the game. If you don't read the game manual, you may accidentally neglect a very important rule, and then all of a sudden your robot or strategy is not actually legal per the rules. So having a thorough understanding of the game manual is vital. I know the page count can look intimidating at first. A lot of it is fluff because of the appendices, like with Appendix A, it's just all the dimensions. Ultimately, looking at the key rules, the G rules, the SG rules, the robot rules, the I'm blanking on skills rules, and there's another major thing I'm currently blanking on. But reading the bullet point main rules is a great way to start if you're if you're initially intimidated by the page count. And then trust me, once you start reading through the game manual, you're going to have questions. And that's a good thing. That means you've actually read it and you've meaningfully engaged with it. So after you have questions reading the game manual, engage with your team. Ask one another, hey, I had this question about rule X, Y, and Z. I'm not sure how this works. And then oftentimes, different people will have tended to focus on different parts of the game manual and they'll say, oh, yeah, rule X, Y, and Z said this. Okay, thank you. So try to answer it within your team itself. If you're having a hard time answering the question, then maybe reach out to other teams if you have contact with them. Like, hey, our team had a question about this rule. If no one's really able to figure it out and you've really found a gray area in the rules, which do exist, you can go ahead and ask on the official Q&A to get an official response from the game design committee. And oftentimes there's good Q&A questions are conflicting wording, there's an unclear definition, there's just generally a gray area you're trying to parse out a little better. In order to post on the official Q&A, you have to have a registered team, so your coach will have to be the one that posts it on there for you if you don't have access to the Robot Events account. Just make sure you're following the Q&A guidelines of going through all the previous questions to make sure your question has not already been asked, and that way we keep the Q&A clear of any clutter. But if you read the game manual and you don't have any questions, you haven't read the game manual. Because trust me, you'll find something. And the game manual is excellent. the last few couple of seasons, it's been very, very, very well written. So it's harder to find stuff than it used to be. Okay, so after you read the game manual, it's actually time to break down the game. So the first thing you want to do is you want to list every possible way to score or actions that enable scoring. And you want to get very specific. Even games that have very, very simple actions. What comes to mind is change up. There was basically put the ball on top of the goal. There were still multiple ways that you could enable scoring. And so I'm going to throw it to the chat again real quick, and I'll know to pause a bit longer this time because the questions came in a bit longer than I expected. But can we go ahead and list out for this year's game, over under, what are some direct ways to score and what are actions that enable scoring? And just to give you one example, this is kind of the easy answer, so I'll get this one out of the way. Picking up a game piece. That's an action that enables scoring. If I can't pick up a game piece, generally speaking, I then cannot manipulate it to then put it into a score position. Now, this year's game is a little different because there's a lot of more plowing, so just simply having a drive base, but you could kind of categorize them in the same general manipulating game pieces category. But what are other actions in this particular game that enable scoring or direct ways to score? And I'll go ahead and set a timer for myself this time so I'm not just counting in my mind. I'll give it about 40 seconds. Ah, there we go. So move a tri ball over to the opponent's side of the field. Excellent. So and we'll come back to that in a minute, actually, in terms of that being a defensive action as well. Excellent. Anyone else? I'll go ahead and start talking a little bit as we're waiting for more responses to come in. So I'll leave the tri balls up to you all unless someone else talks about climbing. But obviously, there are the direct actions related to climbing. So grabbing onto the low bar, pulling yourself up, maybe driving on top of the barrier. Yeah, point enabling is the ability to climb the pole. Exactly. And then kind of digging a little deeper, just to give you an idea of how specific we want to get during this breakdown. Not only is the action of climbing the pole itself an action that enables scoring, but also how you do it. So, for example, I don't know what's going to be the best strategy this year. I'm not going to pretend to know, but maybe there could be a couple of approaches in terms of getting two robots to climb high on the pole. Either you could do like a buddy climb where one robot drives on top of the other and one robot pulls both of them up, or maybe it's more beneficial for both robots to hook onto the pole and both of them independently climb up. So, an action that would enable scoring is building a climbing device that would not take up a lot of volume around the climbing pole itself. So that way your partner is still able to grab on and have themselves climb. Because if you build a climber where you're just hugging the pole and it's all to yourself, then you aren't enabling your partner's ability to climb the pole. So that's how specific you want to get. So try to think of every last little minute little detail and document all in your engineering notebook, which we'll get to during the judging session. But that gives you an idea of how specific you want to be. Another action is, or after you've listed every possible way to score, so the direct actions, putting the tri ball into the goal, putting it onto the other side of the field, you then want to list every possible way to deny or deduct points from your opponent. Because remember, ultimately, we're just looking for the win-loss here. Subtracting or denying points is just as valuable as gaining them for yourself. So there's the obvious ways of denying your opponent points, like pushing them around, blocking the goal, but also, as mentioned before, moving a tri ball over from one side of the field to the other is actually in and of itself a defensive action because you are moving it from your zone or from the opponent's zone to your zone. So you're descoring and scoring simultaneously. And you're going to see this dynamic a lot more in modern VRC games as the cost of building these game elements rises and rises and rises. The GDC has to not cram. The GDC has to be mindful of how many game pieces and elements can actually be present on the field, because it becomes more and more expensive to have just 500 game pieces. So that's why you're seeing a lot more back and forth elements. And whenever you see a back and forth element, that clues you into, oh, okay, by another example would be the rollers last year. By me turning the roller to my color, I'm also descoring. So it's both an offensive action and defensive action simultaneously. So you can list them in both categories. So there you go. So list every possible way to score, every possible way to descore. Next thing you want to do is you want to understand the ranking system. So you want to understand how win points work, how autonomous points work, and strength of schedule points work. And then you need to decide, as part of your game strategy, do I want to be the kind of robot that ranks high, or do I want to maybe design a more niche robot and plan on being picked? What do I mean by that? Well, we're all used to being like, oh, I want to rank high, be the number one seed, and control my own destiny. That's excellent. But another approach is to maybe build a design that's not necessarily going to rank high, but would make an excellent partner and is very complementary to the number one seeded robot. I'll give you an example. Back in the toss-up season, which is probably the most comparable game to this year, there was a team here in Arizona, one of our 18 by 10 members, Alec, he had built a robot that was a wallbot, and it would just span across the field and deny their opponent from scoring like basically any points. It was an awesome robot. I'd look it up after this presentation. I really should have included a screenshot of it. But because it's a defensive robot, they had, during qualification matches, they weren't really scoring that many points themselves, and so they didn't necessarily rank that high. But the number one seed, who was scoring a lot of points, was like, okay, I can either pick a team who, is good, they score points, or I can literally pick someone that denies my opponent's ability to score any points. So it's a more niche robot, and you are gambling a bit more because you're relying on someone else to pick you. But if you really, really go all in and really focus in on that, it can be a very valid strategy. The other thing to consider is that if you are a team that's trying to go for the Excellence Award, where there are ranking requirements, that may be another thing you have to consider, because you need to be in at least the top 30% of the qualification ranking. So keep that in mind as well if that's one of the goals that your team has for the season. Okay, after you understand the ranking system, you need to estimate how many points are needed to win a match, and if they are finite. So in games where there's a limited number of game pieces, there's a theoretical maximum score. So you want to look at, okay, how many game pieces are reasonably going to be scored? What do we think a typical score is going to be in a qualification match and an elimination match? And there's different levels to that. The first tournament of the season, the qualification matches in terms of the number of points you need is going to be very different by the time you reach the state championship. And very often, this will be when you're doing your initial game analysis before you've seen any match videos. And we have the benefit now that it's been a few months. We've had like the Mall of America signature event and various local events around. So there's already some data we can pull from. But if you are looking at the game purely from this just came out, no one's actually played it yet, it's very easy to overestimate how many points are actually being scored, just because in our minds, like, oh yeah, the robots are going to be able to push 20 try balls into the goal in 2 seconds. And then you find out, actually, that's a lot harder than we initially thought. So one useful thing you can do if you don't have prior experience breaking down these games is to actually do this game breakdown analysis on a prior game where there is a lot of data. So maybe break down last year's game spin up and do this analysis. Okay, how many points do I typically needed to win a match? Write that down, and then go look at your region and see, oh, historically it took about 60 or 80 points, I don't know what the actual number is, to win a qualification match in Arizona during the early season. And that gets you a general idea of how capable your robot needs to be during the match. After you do that, you need to ask yourself, is there a chokehold strategy? Now, a chokehold strategy is a strategy that, when executed, guarantees you the victory regardless of the actions of your opponent. This is important to do. Now, the GDC is very much aware that teams want to do this. So the chances of you actually finding a chokehold strategy are slim to none. That doesn't mean you shouldn't look for one, though, because by approaching that asymptote of the perfect strategy, you can arrive at a strategy that gets you almost a guaranteed victory every single time. And it gives you an idea of where there are potential chokeholds in the game strategy itself. Say strategy 5 times fast. I just said that a lot. Make sure we don't have any questions. Okay, I think we're rocking still. I'm going to go ahead, put check marks on those. Okay, so now that we've listed all the actions it takes to score, all the actions it takes to D-score, and we figured out, generally speaking, what it's going to take to win a match, we're going to do a cost-benefit analysis of all the actions we've previously brainstormed. So what we ideally want to do is we want to identify the easiest tasks that provide the most amount of points. And remember, denying points is just as valuable as gaining them. So if there's a very easy way to deny your opponent a ton of points, also keep that in mind. Now, there's a couple of ways you can approach this. What my team used to do is we used to take all of those offensive and defensive actions, and we would give them a difficulty rating on a scale of 10. 10 being this is an extremely difficult action, 1 being I could have my robot do it in its sleep, which robots don't sleep, or do they? AI is a thing. Anyway. So by doing that, you're giving a numerical value to the difficulty of everything. So you're very easily able to sort, okay, these are the most difficult actions in the game. These are the easiest actions in the game. Another option is to purely just rank them. This is number 1, this is the easiest action. Number 2, this is the second easiest action. Third easiest, so on and so forth. I would personally recommend the numerical version where you're just giving each individual action a rating, but that's just my preference. After you've done that, you now want to kind of pull it all together and consider the different approaches to play this game. So, do we want to be the solo scorer, where no matter who I'm partnered with in qualification matches, I'm going to get all my ranking points by winning the match. I'm going to get the autonomous win point, and I'm going to be the number 1 seed, regardless of who's my partner. I'm going to control my own destiny. Do you want to be a more supportive role? So, a robot that might not necessarily do all the game actions, but is an excellent support to another robot? Do you want to go a primarily defensive route? Defensive strategies are still an excellent way to go. Obviously, offense is sometimes more fun. There are some fun defense robots out there, so I don't want to say defense isn't fun, especially anyway. But consider that. You can also do a mix of the two, so an offensive strategy with opportunistic defense. This is all up to you. I'm just giving you an idea of potential approaches you can go with. And ultimately, you want to pick the approach that best fits your team's resources. And what I mean by that is that, again, let's say you're potentially going for the solo scorer route. I'm going to control my own destiny. I'm going to build a robot that can launch all the tri-balls onto the other side of the field, push them all in, and then I'm going to hug my partner and pull them up to the top of the pole, and both of us are going to be at tier, I think J is the highest, all by myself. If you're a first-year team, maybe don't want to do that, right? Maybe look at focusing on the actions that are the easiest, that provide you the most amount of points. Not to toot my own horn a little bit, but the very first year that we competed in Vex, we're like, okay, we're going to build a pretty simple robot because we've never done this before. And so we identified in this particular game, it was Skyrise, that scoring the Skyrise sections was a very easy action, relatively speaking, that got you a lot of points. And our robot pretty much primarily focused on that, and we did excellent that way. So that's more than valid to just focus on one thing, do it really well, and it's a totally valid approach. Okay, the culmination of everything you've done here is going to be making a priority list. So I've determined now, okay, this is the best way to approach the game from our team's perspective. The form that's going to take is by creating a priority list. Now, I've kind of spoiled it a little bit with the first 2 items here, but number 1 on your priority list, almost without exception, unless it's a very, very funky game, is going to be traversing the field. The reason for this is that if you cannot drive around the field, you can't do anything. I can't push tri-balls around. I can't drive to the pole to climb. I suppose theoretically you could set up your robot next to your climbing pole and then just like reach out, but niche strategy, and I don't know if I would necessarily recommend that. You want to be able to drive around the field. So number 1 should almost always be traversing the field. Now, there's a very interesting dynamic this year in that it's not just, okay, we have a flat ground and I need to determine whether or not I can move, yes or no. The answer should be yes. This year, you actually have a couple of options. Do I want to build a robot that has the ability to drive over the center barrier? Or do I want to build a robot that's only going to drive on flat ground? I'm never going to drive on the barrier. I'm only going to take the under or on those underneath the climbing poles, or build a robot that can do both. It's able to get over the barrier as well as drive underneath the climbing pole structure. Ultimately, that's up to you. Generally speaking, it's best that your robot is able to drive over all obstacles on the field. That way, you don't have any choke points where, oh, I know they can't drive over the barrier, so I'm just going to sit here underneath the climbing bar and I know they can't escape. You want to avoid situations like that and be as resourceful as possible. Number two on your priority list, kind of speaking back a little earlier, is almost always going to be acquiring the game pieces. If you cannot acquire or manipulate the game pieces, you ultimately cannot score them. Now, it's interesting in that this year, we actually have, again, this is okay, just a sidebar. I love this game. I think it's awesome. I think the GDC did an excellent job on the game this year. There's a lot of different ways you could play this game. But, side note, bar over. In terms of how you want to acquire tri-balls, you can either acquire them from the floor, or you can acquire them directly from a human driver that's loading them directly onto the robot. So you need to decide what's going to be our number two priority. Is it going to be picking up tri-balls from the floor, or is it going to be acquiring tri-balls from a human loader? That's ultimately a you decision. But in some shape or form, number two should be acquiring game pieces so that you can eventually do something with them. And then from there on out, the rest of the list, that's entirely up to you. Is the next most important thing having a wide wingspan so that I can push a lot of tri-balls into the goal at once? Is it doing a low climb? Is it doing a high climb? Is it having a net so that if my partner is shooting tri-balls across the field, I can catch them and then put it into the goal? There are so many ways to play this game, which just makes me so excited that I love this game. But ultimately, this priority list is going to drive your robot design for the rest of the season because it's going to clearly lay out, okay, this is the most important action game. This is the second most important action in the game. And you should always keep that in the back of your mind. The reason for this is that it's very easy to get fixated on some other side task that's like maybe number 7 or 8 on your priority list, but you're dumping a lot of hours into it. But then it's coming at the expense of maybe your drivetrain's not that good anymore. But wait a second, on our priority list, traversing the field is number 1. So really, from a priority standpoint, we should be prioritizing the drivetrain because it's the number 1 most important thing. If our drivetrain breaks because we didn't build it that well, we're out of luck. There's nothing else we can do. In the same vein, it's also very important to list what is out of scope. So you want to make sure that, let's say you've determined for our team, it's too difficult to climb to the highest level. We're going to leave that to someone else, or we don't think it might not even be strategically necessary. Another thing that GDC likes to do is they like to throw little nuggets into the game of it's very, very, very difficult, and it's actually not a very high payoff. One example I can think of is and this is a little debatable, so it's not clear cut. And this is part of the beauty of Vex game design is that you can debate these points. But getting the rings on the high post in Tipping Point from a couple of seasons back in an actual match, not during skills, but in an actual match, that was very, very, very difficult to pull off. And in the grand scheme of things, it was much more important just to make sure you got more mobile goals and you balanced. Who won the world championship? Not a high post, robot. It was just normal metabots who are able to drive well, collect rings, put them on the low alliance goals. That's all you need to do. So it's important not to get too caught up in the most flashy parts of the game design. All right, how are we doing on time? 9:51. Remind myself how long we have here. And give myself an opportunity to drink. My throat is quite dry. Until 10:30. Okay, we still have 40 minutes. We're doing just fine. Okay. And I had spoken about this before. So your priority list, it's going to basically stay constant for the entire season. There are a couple of reasons why you might want to change your priority list, and this is something you would clearly document in your engineering notebook. Maybe your team's resources changed. Maybe your number one limiting factor was we just don't have a lot of money, but all of a sudden mid-season, hey, we just got a big grant and we're going to able to buy a lot more. We're able to buy a pneumatic kit we weren't able to buy before. Or maybe the difficulty of an action changed. Let's just say, using this year as an example, right now it looks really hard to climb super, super high on the pole combined with all the other actions, like in terms of being able to score tri ball as well as in the you got it. Sorry, I spoke there. Um, so let's say someone posts a YouTube video at some point and they're like, oh yeah, I figured out how to do a high climb with a 5.5 watt motor, and that's it. And it does it in half a second. And it ends up being that climbing is actually very, very easy. And initially you had anticipated this is the most difficult action in the game. Well, now that it's super easy, you're going to have to do it, right? So those are kind of the two primary reasons why your priority list might change mid-season. But otherwise, it's probably going to be the same for the entire season. This is why it's very important to do a thorough analysis at the start of the season. So that way you have a very solid foundation for the rest of the season. And it's also excellent for engineering notebook. Okay, we kind of just finished a major section here, so I'm going to just pause for questions real quick. So that's a summary on breaking down the games. Remind myself. Yeah, because then we're moving on to brainstorming. So does anyone have any questions about how we do the game analysis? How do we break things down? I'll go ahead. It took about a minute last time, so I'll go ahead, set a timer for 1 minute, and we'll be back very soon. I'm right here the whole time, obviously, but this is the one downside of doing remote. It's reminding me of COVID presentations when you were just waiting for the delay in the stream. Okay, it's been a minute. We'll go ahead and move on, and if I see a question come in, I'll go ahead and jump back to it. Okay, so we've conducted our game analysis. We now know what the best approach is to play the game for our particular team. Now it's time to turn that into what we're going to be building. So this is where you're going to start brainstorming ideas based off of your priority list of the robot actions you must complete. So if you have things like your drivetrain, acquiring a game piece, this is where it's time to brainstorm individual mechanism ideas for each one of those actions. So I've posted an example below here, and this was for a game, Turning Point, of a number of years ago. This just gives you an idea of how many ideas you can think of. And to clarify, brainstorming is not the time where you should be filtering ideas. This is the time of the year where you just get it all out there. Just any crazy ideas you have, put them on the paper, because an idea that seems absolutely insane at first might actually end up being a great idea. Ultimately, you're going to apply a filter later in terms of what are actually ideas that would be practical and ideas that are just too crazy. But we have an excellent example of this now. So, if you haven't already heard of it, one potential action, and this was specifically for VexU, so for VRC teams, you couldn't do this. But for VexU teams, they realized that the phrasing of the rules didn't specifically state that you couldn't D-score discs from the high goal in last year's game, as long as you didn't actually touch them. So VexU Pyro had this idea of having an air storage tank and then blasting air out, so decompressing the air out so that they would push using air, knock the goals out of the disc. That's one of those ideas where you throw it out there at the start, saying like, wouldn't that be funny? Wait a second. And then realizing you can actually do that. That's not to say that you'll always find something like this, but you want to get those crazy ideas out there because one of them might end up being practical. And I would also recommend during this time that you should not be looking at the internet or getting ideas from other teams. This period of the design process should purely be ideas from your team itself. And there's actually an added category on the notebook rubric this year that talks about creating original ideas. If you are truly isolating yourself to the ideas that your team is generating, this will come very, very easily. But brainstorming, just get all the ideas out there quickly. Okay, so, and just to give you an idea, so like, you for this year, you might brainstorm different drivetrain designs. You might brainstorm different intakes. So, how can I acquire the tri-balls? Different shooters. So, how can I launch the tri-balls, like catapults, flywheels, so on and so forth. That's the kind of thing you're doing during this part. Once you have completed brainstorming within your team itself, now it's time to expand your horizon and get ideas from other people. So, robotics games have been around for a long time. There's no need to reinvent the wheel. So, it's important to know your robotics history. And there's a prior games page for VRC. You can also look at other programs like the First Robotics Competition, First Tech Challenge. You might find similarities. And while these are not going to be direct one-to-one comparisons, most often the case, sometimes you'll find, you know, a ball is a very common game element, right? So if you see any game with a ball, a ball is a ball is a ball. And it's just a matter of how big it is, its mass, and if it's useful for that particular game. So looking at intake mechanisms for a ball is usually going to be generally fairly universal. This game is pretty darn unique, though. I don't think we've ever seen a game object shaped like this before. It's similar enough to a ball that a lot of intakes that are used to acquire balls could also be used to acquire tri balls, but it's not necessarily one to one. And then the climbing challenge is also fairly unique just because they put that cap on top of the post, so you can't use the starstruck climbing method where you'd hook into the top. So anyway, just to say, there's a lot of prior mechanisms out there that you can pull from. In terms of the game that's closest to this one, I would say Toss Up is probably the closest just because it also had the barrier element and it also had a bar that you wanted to drive underneath, picking up balls. It's similar, but it's not one to one. So you don't want to just copy paste designs. You more so just want to see, okay, how were teams solving the problem this particular year? Because the teams in those seasons were making priority lists for that particular game. So maybe number one on your or number two on your priority list is, or I'm sorry, let's do number three. Maybe number three on your priority list for this year is climbing. But then you look at a past game that also had a very similar climbing challenge. But the teams that were solving the game challenge that year, it was like number 7 or 8 on their priority list. So they weren't necessarily putting a lot of resources into it when you should be. So that kind of gives you another idea as to how these aren't going to be one to one, but you can draw inspiration from past games. And then last but not least, how would a person complete this? Like just in real life and just drawing inspiration from that. How would my hand do it? Just you don't have to limit yourself to just, oh, I gotta only look at robots. Look beyond that scope. Okay. And this kind of goes back before. It is foolish to just blindly copy other people's designs. And this applies to copying designs from previous games, but also just copy and pasting someone's design from this year. So, like I said before, there's already tournaments out there. You can see fully constructed robots, but you want to evaluate why did that particular team build that robot? And would it be useful for my team to build that myself? Oftentimes, what's going to be more useful is to look at one particular mechanism another team's robot. Like, oh, yeah, they got that complete robot. But I really like this team's intake design for intaking the tri-ball. I don't necessarily want to copy them exactly because ideally you should not be just copying. You should actually be formulating your own ideas, evaluating everything independently. But if you like a particular element, taking that, pulling it and bringing it to your robot and combining all the best elements into the ultimate design. And kind of what I was saying before, different games had different priorities. So just be careful in terms of blindly copying. And then you're ultimately going to want to prototype these mechanisms to prove that they work for your team. So let's say you do find a design that's useful and you want to try building it. Excellent. Just make sure that you have the ability to build it yourself because sometimes they can be quite tricky and you might not actually have the ability to try it. Prototypes are just meant to be rough and tumble. I just need to build this quickly, proof of concept, see if this works. This is not, I'm going to get the exact geometry ever so perfectly. You don't even necessarily need to cut metal if you can at all avoid it. If they look super, super jank, that's totally okay. In fact, I would encourage that just for the sake of doing things quickly. Kind of mentioned it a few times offhandedly, but I'm sure we all know how to do this. But just in case, YouTube is a great resource for finding potential designs. And I like doing this is much easier now than it used to be. Back in the old days when I was in high school, which was, I don't want to think about how many years ago, there weren't that many videos of matches out there. And so you can use search terms using the current game, Vex prototype, Vex match, qualification, finals, mechanism reveals. You can also sort by upload date. That helps filter out all the old stuff and bring in only the new things. So that's a handy way to find things quickly. All right. Now, when you are looking at videos on YouTube or wherever, maybe TikTok has videos now. I don't know. I don't have TikTok. And by videos, I mean like robot videos. Be cautious of flashy reveal videos. It's very easy to make a, I'll be frank, bad robot look awesome. And I'm speaking from firsthand experience. I had made a robot reveal video for one of our robots, and it wasn't that good, but with some sharp editing, a catchy song, quick cuts, you can make any robot look really freaking good. So just be cautious of taking ideas from those robots. Match videos are going to be your best friend because those are just the robots out in the wild, no filter. It's just they're doing their thing. And if they're doing well in an actual competition context, excellent. Teams also share ideas on the Vex forum and on Discords, so you can find resources there. Another excellent resource is to visit or volunteer at local events and just talk to teams one on one about their robots in between matches. Like, hey, I really like this mechanism on your robot. Can you tell me more about it? And in my experience, most teams are happy to talk to you. You just like, oh yeah, we did XYZ, yada yada yada. So just again, going back to networking and collecting ideas from other teams. Just keep in mind that if you do end up using any of ideas from other folks, to credit them in your engineering notebook. And we'll go over that during the judging presentation, but just be mindful of that when you are collecting ideas from others, to cite properly. Plagiarism is bad. Okay. So now that we've brainstormed all these ideas, we thought of them and we've gathered them. Now it's time to narrow them down to the ones we actually want to build. So what I would recommend doing is doing a design matrix. So for each individual category of mechanism that you're going to be prototyping, have a design matrix that evaluates its viability. So for a drive, this is an example from a notebook that was on the RC's website of an exceptional notebook. So this one was talking about drive. So they have compatibility. That's talking about the ability to attach stuff to it. Structural integrity. So just, is this thing going to hold up within the rigors of the competition? Is it fast? Does it have enough torque? And the weight of it itself. That's just what this particular team decided to do for the drivetrain evaluation. If we were doing an intake, I would maybe want to look at the ability for it to be a touch take mechanism. By a touch take mechanism, that means the moment my intake touches it, it's mine. I don't have to like wiggle around, try to get it lined up oh so perfectly. The moment my intake touches it, it's in. How quick it is, how well it holds onto the game piece. If someone hits me from the side, am I going to let go of the tri ball? That sort of thing. Once you decide the categories for what you're evaluating, you want to give each category a weight. So the easiest way is just rate everything on a 10 scale. So compatibility 5 out of 10, structural integrity 5 out of 10, speed 7 out of 10, fork out of 10, torque 4 out of 10, weight 6 out of 10. But the better way to do it is to give different categories different weights. So let's say speed is very, very important to your team. Let's say it was a wide open field like it was last year with spin up. Getting a high top speed is very important. So maybe I would want to say, okay, that's a very important category. I want to weigh that more. I'm going to rate evaluate each prototype on a scale out of 10. But then let's say weight isn't a big concern. Like I can be a big heavy robot. I don't really care. So I'm going to only make that a rating out of 3. So I'm only going to evaluate the weight of drivetrains on a scale of 1 out or of 0 to 3. And then that way, the most important aspects of the design are going to be weighted higher instead of putting them all on an even playing field. This design matrix is not an end all be all. So once you've evaluated all your prototypes, you'll have a numerical score for each one of them. And it's not a hard set rule like, the X drive got the highest score. I guess that's the drivetrain we're going with. It's meant to just be part of your filtering process. So don't you're not going to nail the weights of your design matrix on the first go around. Use some discretion on your team to evaluate things appropriately. Once you've determined what the best prototypes are, build them, construct them. There's a picture on the right of a drivetrain we built one year, and that's just a prototype. You can see it's not super good. We haven't didn't cut any metal on it. We slapped some weights on it to get an idea of how it would handle the additional weight being on there. That was it. And the prototypes are useful to just get a general sense of the geometry of how things are going to work. This is especially useful early on in the year when you don't have anything to reference and you're just trying things out for the first time because you don't necessarily have an idea of how much space is this mechanism actually going to take up. So you build it once, very rough prototype. Oh, it's about this big, and I think I can make it smaller by changing X, Y, and Z on it. Alternatively, instead of building individual prototypes for every category of mechanism, so building a prototype drivetrain, building a prototype intake, building a prototype shooter mechanism, building a prototype climber, so on and so forth, some teams like to just go straight to building a complete prototype robot. I would not necessarily recommend this for teams who are less experienced just because unless you're very fast at building, it's hard to build a prototype robot because then you got to build the whole thing and take it apart. The benefit of it is that you're able to more quickly see how the systems integrate with one another, but again, it's much more difficult to do in a timely manner. So I personally prefer the method of building the individual prototypes, evaluating their viability, and then combining them into a final design later. But again, ultimately, that's a you decision, whatever you think is best for your team. And this just gives you an idea of some prototypes that we built for In the Zone a number of years ago. So you can see, started from just a whiteboard, figuring out the geometry, the very first jank prototype, a little less jank, a little less jank, and then until finally we got to the final product. So again, prototypes don't have to look pretty, and they probably should. If after all that, you're like, I don't even know where I'd start. I haven't built a Vex robot before. I don't even know what to do first. Where do I even begin? What I would recommend doing is building the Hero Bot. So that is a robot you can build out of the standard kits from Vex that are able to play the game in a very basic way. This is very useful for just getting acquainted with the Vex parts and understanding how they work. Because if you've never interacted with the parts before, you don't necessarily know what you're doing. Building the standard robot gets you familiar with everything, and then you have a nice little robot that can play the game. I would not recommend sticking with it. It's meant as a starting point. It's not meant to be like, this is the best robot in the world. It's going to win your world. You are ultimately going to be able to build a better robot than the Hero Pod, but it's a great way to get started. Another excellent resource is the Vex Forum. There are years and years and years of prior posts from people who have built basically every mechanism under the sun. So if you search the mechanism you want to build and put in the site vexforum.com, you'll get a lot of results for what you're trying to build. So I just put an arm site vexforum.com and I just got a bunch of results for various arms. And also, you can attend our very own Build Tips workshop, which will be this afternoon. All right, I will go ahead and pause for questions again before we move on to consolidating all those ideas down into a final robot design. I'll go ahead and wait 1 minute again. We have what, 20 minutes? Okay. I think, yeah, we should be good. We'll finish on time. And we have that 15-minute buffer if it comes to it. Okay, I've waited about a minute. If I see a question come in, we'll go ahead Oh, I did unmute myself. Okay, good. Didn't want to make that same mistake again. If I see a question come in about that, I will come back. Otherwise, I'll go ahead and move on. Okay, so now it's time to bring all the ideas together to make a final robot design. So based off your prototype results, we're going to be properly testing them, designing a testing process, and evaluating them, getting hard data. We'll go over that more in the judging portion. And keeping your priority list in mind, it's time to design your robot. Now, in an ideal world, you would take the best prototype from each one of your mechanisms that you need to build and combine them together into a super robot. So I would take the best drivetrain, the best intake, the best shooter mechanism, and the best climbing mechanism, and I combine them all into one robot, and I can do them all. Unfortunately, you only have 8 motors of the 11. We only have 8 of the 11-watt motors. I have to be careful now because now you can use some of the smaller motors in combination with the big motors. But generally speaking, we'll say 8 of the big motors, right? So a lot of your best priorities, maybe they required multiple motors. So my drivetrain required 6 motors, and my climber required 3. My best intake required 2. Well, all of a sudden, you already don't have enough motors to do all those things together, right? So this is where the hard part comes in. This is where the real engineering challenge is. How do I compromise? Where do I cut on mechanism design? And where do I keep? And this is where your priority list is important because you don't want to compromise on high priority items. You ideally should not be compromising on your drivetrain. You should ideally not be compromising on your ability to intake tri-balls quickly and effectively. And number 3 on your list, scoring tri-balls, would most likely be scoring tri-balls in some fashion. Ideally, don't want to be compromising on that, but they're ranked for a reason. If you're at a point of where I need to take a motor from something, where do I take it from? Look at your priority list. What is the most important action? And go down from there. So that's how you're going to combine things together is you're going to look at your best prototypes, try to combine them best together, and then use your best judgment to compromise as seen fit. Now, another thing is sometimes you can take different mechanisms and you can combine them together into one mechanism that's able to do 2 separate things. This is awesome and where you can see a lot of really creative designs. Trying to think of an example from a prior season. I am blanking. I have a funny example though. You might be wondering why I randomly have a pen on the screen. So this is a cautionary tale. So sometimes you can take, let's just say you're able to combine. Oh, perfect. Let's say you're able to combine your intake and your shooter mechanism. So you're able to intake a tri-ball, and then that exact same mechanism is able to shoot it out. So you've combined both the shooter and intake into one mechanism. Everything's sunshine and rainbows. Fantastic. The only thing you want to be careful of is oftentimes combining 2 separate mechanisms into one can compromise on the ability of both of them. So it would have been better if you had just done them separately rather than trying to combine them together. Now, combining them together, again, is great from a judging perspective as well, because if you showed you've innovated, but it can also just hurt you. My favorite example of this, and this is probably just a me thing, but I think other people are like this as well, are these stylist pens, where it's a pen and it's a stylist as one. I think they're clunky and a piece of junk. I would much rather have a dedicated like Apple Pencil, like a really nice stylus and like a really nice ink weighted pen separately rather than trying to combine these 2 pieces of junk into one thing. That's awful. Just to give you an idea, right? And maybe there's someone out there who's an entrepreneur like, I made a pen stylus combo that's best of both worlds. Good for you. I haven't seen it yet. Just to give you an idea. Okay. Now, when you're designing a robot, just keep the KISS principle in mind. Keep it simple, sweetie. You don't need to make things too complicated for yourself. In fact, the more complicated your robot is, the more points of failure you are going to introduce. So when a robot inevitably breaks that competition, and it will break, it's just a matter of how badly it breaks. If you have a simple robot and you can just very easily, okay, take these 4 bolts out, take this piece of metal on, pop that on, we're good to go. Versus I have this super complicated gearbox that shifts this transmission here and it does. You might be able to do that. Like your team is resourceful enough to build a robot that's that complicated. But oh, howdy, is it going to be a pain in the butt when that thing inevitably breaks. So try to design your robot to be as simple as humanly possible. You also want to design for tolerating error in mind. The build tips is going to go over this a bit more. But if you find yourself
saying, "Oh, if my robot is ever so perfectly lined up, like it has to be like within zero point 0.1 inches to make my autonomous routine work ever so perfectly." You've designed your robot in a less than ideal way. You want to try and build your robot that no matter how you slam into whatever you're trying to do, it accomplishes it regardless of how off you are. Within reason, of course. If you're driving backwards or something in the exact opposite direction, only so much you can do there. But you want to try and tolerate error. And kind of in the same vein is ease of control. You don't want to have to pull off a button combo on your controller in order to score a try ball into the height or into the goal. You want to ideally just be able to press, a button. Maybe you've got some sensors to automate some mechanisms, and the robot does everything for you. So you want to be control like a video game, just like nice and easy and responsive. Another thing to keep in mind that's not necessarily applicable this year because you can only hold one tribal at a time, but especially last year, do not underestimate the difficulty of transporting game pieces inside of your robot. And what do I mean by that? The action of getting a game piece from the floor in your intake up to a shooting mechanism can actually be quite difficult. You got to make sure that there isn't too much friction so it doesn't get caught. There isn't a pinch point. If multiple game pieces come at once, does it get jammed in the belt inside your robot? So don't under this. Oftentimes we think, I built a shooter mechanism, I built an intake, and I'll just like, I don't know, throw a belt between them to connect the two. Oftentimes, a lot of time wasted and where points of failure are going to be in that transportation process. So don't underestimate that difficulty. Another big thing, be prepared to encounter rigorous interaction. The way I like to put it is that if you're not comfortable with slamming your robot against the wall or other robots slamming into you at top speed over and over and over again, your robot's not built well enough. You got to reinforce it, add more triangular braces. Build Tips is going to go over this more, but you should not be afraid to get slammed or slam into other robots. VRC games are meant to be interactive. Defensive actions are encouraged and very much part of this game. So don't, if your robot falls apart because someone breathed on it, that's on you. Okay. So after you've reached a consensus on your final design, so you've kept all of those principles in mind and your team has come to a consensus. All right, this is our robot design. Let's do this thing. Go ahead and specify as many dimensions as you can. If you're doing a handwritten or if you're doing a hand sketch, try to include it as much as to scale as you can based off the actual dimensions you got from the prototypes that you built. Or if you have the ability to CAD your robot, that's an excellent resource. There's some examples on screen of some potential programs that you can utilize. Just a way so that way you can get an actual sense of how big your robot's going to be and what you're going to be building. And then, okay. So this is all going back to the engineering design process. So ultimately, we've kind of been through a couple design cycles at this point. So we've identified the challenge. We've brainstormed solutions. We've identified new challenges in terms of mechanisms we're going to build. We've evaluated those prototypes. We've wrapped them all together. Now I've built my full robot. I've coded it and I've competed with it, or maybe I haven't competed with it and I've just built the robot not quite not quite what you wanted. It's important to evaluate your design after major milestones. So major milestones are typically going to be your tournaments. So usually your deadline for finishing a robot and driving with it is going, well, I would hope that your deadline for finishing the robot's like maybe a month before your first tournament. So that way you can actually give the programmer some time to program and also your driver some time to drive practice. I know how that goes sometimes though. So after a competition, that's an excellent time to evaluate what worked well about our design, what didn't work well. Did it follow our priority list? And do we need to either refine this design or do we need to completely redesign? How the season typically goes for teams, and this is not a hard set rule again, this is just how I've seen most top teams go. They'll generally have an early season robot, so a robot that they compete in the winter months. So in November and December, they're competing with one robot that they built over the course of the summer and fall. Then over winter break, they'll rebuild to a new robot, or they'll do like a major um, uh, overhaul of their current design And the reason for that is that typically now that you have a bigger sample size of prior tournaments to look at, you can see, oh, there's this cool team in Nebraska or Canada, wherever. It has a really cool design, and I want to incorporate these two elements of their design into a new design. So that's why you'll oftentimes see a winter rebuild. And then you'll usually have teams that keep those designs, they'll iterate and change them, or keep them mostly the same, but iterate on them up into the state championship. And then if you're fortunate enough to qualify for the world championship, you will then sometimes build a world's bot. So again, after having the benefit of seeing all prior state championships, you might say, okay, I think this design is going to work well for worlds, just tweak a couple things. Or I don't think I'm going to be competitive at worlds. I want to be competitive at worlds. Again, part of the fun of going to worlds is just the experience. So personally, there's no shame, in my opinion, there's no shame of just going and having a good time. That's not to say don't try, because you do still have alliance partners. You don't want to just show up with a brick and be like, I'm at Worlds. Do try to do your best at Worlds, but sometimes completely rebuilding, because it's a very short time frame from states to Worlds. Not all teams necessarily have the ability to completely redesign the robot in that small time frame. So just be cautious of it. Okay. We're going to pause for questions one more time, and then we'll briefly go over team structure in the last 8 minutes we have here, and we'll go from there. I don't see any questions coming in. Again, if I see them come in, I'll go ahead and go back to them. Okay. Just to kind of tie all things up, I just wanted to briefly go over team structure. So, on your team, it's helpful to have team roles to ensure tasks get completed. Now, don't just arbitrarily restrict your team members to these roles. Like, let's say someone has been given a builder role. They don't and should not exclusively build the robot. Ideally, everyone is contributing to everything. These are just more your areas of focus where you are putting in more of your effort, and you are responsible for that portion of the team or robot to get completed. You can have as many team roles as you want. Here's some samples that I've got. So, builder, responsible for building the robot; programmer, responsible for programming the robot; strategist. So, this is someone who is responsible for your team's strategy in terms of how you play the game. This will oftentimes be your lead scout at competitions that we'll go over in the competition tips presentation. They'll be like watching videos, gathering data from matches, and seeing where the winds are blowing in terms of how this game is being played. Having an engineering notebook manager, so someone who's making sure that everything is being documented in the engineering notebook. A general project manager, so just making sure we're staying on time, or we're meeting our deadlines. We have a timeline. We're documenting that in the notebook, and just making sure things staying on track. And then a researcher, so someone who is still actively out there looking at other designs, looking at prototype videos, and finding out, hey, I saw this really cool mechanism from a team. It's kind of like similar to our mechanism, but they did this one little thing differently. I think we should try it. So having those roles are helpful. And again, don't pigeonhole someone to only that role. That's not fair for them. It's not fair for the entire team, but it's nice to make sure that each area is being accounted for. And you can take on multiple roles. In terms of making decisions on your team, consensus is key. And consensus isn't just everyone gets to speak up, it's everyone is actively listened to and everyone's ideas are seriously considered. Ultimately, you are going to find points of disagreements on your team. It's just inevitable. It's part of working as a team. But it's important to reach a consensus on ideas. That means everyone is able to speak, everyone is listened to, and everyone understands, even if they disagree with the approach, why the team is making the decision it is making. So it's important to always have discussions as a group when you're making major decisions as a team. And again, value everyone's input and truly value it. Don't just say, Jim Joe over here says he wants to do this, but we don't actually listen to him. Do listen because they're a member of your team and they deserve to be heard. Be objective as you can. Whenever you can use data to back up your decisions, that's awesome. And if you have data, you should be putting that in your notebook. Um, but that helps remove feelings of, oh, I feel like this is the best approach. Well, is there a way that you can quantitatively prove that that is the best approach? And in the same vein, using data and metrics. And then also know when to let go. Sometimes you can get really, really attached to an idea and like it becomes your baby and you're like, we have to do this thing. It's the best thing ever. And everyone's looking at you like, about that, and you've been given data that suggests it's not a good idea, but like you thought of it and you think it's an awesome idea. Sometimes you need to know when to let go and decide, okay, the team wants to move in this direction. I understand why they want to move in that direction. I'll go ahead and give up that idea because it's not going to be the best approach. Okay, student involvement. So VRC is ultimately a student-centered program. I'm just going to go ahead and read G2 verbatim because I think it's excellent. So, VRC is a student-centered program. Adults may assist students in urgent situations, but adults may never work on or program a robot without students on that team being present and actively participating. Students must be prepared to demonstrate an active understanding of the robot's construction and programming to the judges or event staff. So, some adult, excuse me, some amount of adult mentorship, teaching, and or guidance is expected and encouraged facet of the VEX competitions. No one is born an expert in robotics. However, obstacles should always be viewed as teaching opportunities, not tasks for an adult to solve without students present and actively participating. I'll just give you a quick anecdote. Part of the reason why I started a VEX team is because I was part of a prior robotics organization. That was great, but there was a lot more adult involvement and it was considered acceptable in that program. But the students didn't, including myself, and I spoke to other students who felt the same way. We didn't feel like we had ownership of the robot, that even though we had input, the robot we ended up building was ultimately not ours. And that was very disheartening. So, this is for the benefit of the students. They're going to learn a lot more without the adults interfering, and they're going to feel like it's truly their robot and it's their program. And that's how you want them to feel. If you're an adult coach, it should never feel like your accomplishment. It should feel like your student's accomplishment. So if you ever find yourself wanting to do something and maybe stepping in, step back. You can, of course, provide teaching moments, but, and like the rule says, no one's born a robotics expert, but you want to speak in general terms and let your students be the ones who do the work. And the REC Foundation Student Centered Policy expands on this. Part of the program, adults can't build the robots or program them or give you ideas. And then in terms of the actual responsibilities of the adults themselves, you're there to enable your students for success. So you can just be the adult in the room. So if you need to be there to help facilitate discussions, teach basic skills, provide resources. So if you're at a tournament, make sure they're getting plenty of water or food, provide encouragement when inevitably, you have a not so great match and, spirits are down. And like I said, just generally speaking, be the adult in the room since you have a bunch of high school and middle school students. And then last couple of things here. I know we're at 10:30, but this is why we have that 15-minute buffer just in case I go a little over. In terms of how frequently you should be meeting, age groups are largely going to determine the length of the meetings. I found when middle school students are typically their attention span's only about 2 hours, and even high school students to a degree. So back when I was on a team, we met 3 times a week for 2 hours. Well, on Sundays we would do for 3 hours, but inevitably by the end of hour 2 and going into hour 3, our attention spans were kind of lost. We were kind of just goofing around at that point. So it's important to put in productive work. Don't just have super long meetings for the sake of having long meetings. Have shorter, more frequent meetings if that means you'll be more productive. Typically, you're going to have more meetings towards competitions just because you're trying to panically finish the robot. If you can meet over winter break, if that's a luxury your school provides, highly recommend that. And in terms of tournaments, those are going to determine your deadlines. You can abstractly know, okay, we're probably going to go to a tournament in November-ish, but sign up for those as quickly as you can. At least in Arizona, we'll be getting those posted um, probably about in the next month. Most tournaments are posted by about October 15th. I need to look at the qualifying criteria again. That might be an old date. And that's my apologies for not updating this slide. But generally, by that time frame, you're going to know the tournaments for the season. And then making sure when you're making your timeline, have a cushion in it. So everything's always going to take longer than you expect it to. So try to have more ambitious deadlines. So that way, when you inevitably go over them, or if you beat the deadline, that's even better. You have even more time for driver practice and so on. All right, last point here is your practice field. So this is another big question I get a lot is, do I need to buy the full honkin' field in order to practice with my robot? Answer is no. The first 3 years that Phoenix Lights existed, they did not own a full field. It wasn't until year 4 when they finally got one. And you can honestly practice with just the minimum number of game pieces. So the very first year, we just practiced on the hardwood floor. That was it. Now, I would recommend getting the actual official field foam tiles. The reason for this is that if you're programming your robot's autonomous routine, you want it to be driving on the actual surface it's going to be driving on at competitions, because the amount of friction between the wheels and the tiles is going to be different from than if you're driving on like kitchen tiles as opposed to the foam tiles. And that's going to mess up your robot. So ideally try to purchase at least half a field of foam tiles so that way you're able to practice your autonomous routines. Beyond that, just purchase the minimum number of game pieces. So if you are depending on your team's resources and your strategy, just buy the number of game pieces that are needed to actually test it. If you don't plan on climbing, you don't need to necessarily buy the elevation bar if you're just going to be shooting tri balls. But and you can also have low resource things like the goal is just made a PVC pipe. So if you just want to purely practice with driver, not necessarily doing the autonomous routine, you can just build one that yourself. Okay. And those are, but I will say that if you do have the ability to purchase the field. It does wonders. If you just don't have the budget to do it, totally understandable. I was in the exact same boat. Go practice with other teams. There are multiple teams in the valley that if you just ask them, hey, can we come over and practice on your field? Like, yeah, sure. Come over on Tuesday at whatever. They'd be more than happy to help you. Okay. We're gonna go ahead and break for it looks like I went about 4 minutes over, so about 10 minutes. So the next presentation, which is Judging and Engineering Notebooks, is going to start at 10:45. So we'll take a brief break here and I will be back soon. And if you have any questions, feel free to leave them in the chat. I will try to answer them during the break. All right, thank you. I believe so.
I need to get better at unmuting my microphone. Thank you, chat. I appreciate it. Um, I thought I had unmuted myself. That is my bad again. All right. My name's Nathan. You know who I am. We're going to be talking about judging. We're going to be talking about the judging process, engineering notebook, and the interview. Okay. So, what are the judges looking for? So, this is a magical question that is very mysterious, shrouded in mystery. What are they looking for? Well, actually, we know exactly what they're looking for because it's outlined in the Guide to Judging. The Guide to Judging is the process and guidelines of how teams are going to win awards at events. It's meant as a resource for both the teams and a resource for the judges themselves. Okay, just got another comment. There doesn't seem to be any audio coming through. I don't know if that is the delay. Because now on OBS, I have unmuted myself and I can see the levels. I'll wait one more second. If you can hear me now, and it's a 1 minute delay, so it's a bit brutal right now, can I just get one more confirmation that you can hear me before I proceed? Okay, actually, I just unmuted myself on a separate tab and I can hear myself, so I think we're good. Okay, cool. Okie dokie. So, Guide to Judging. So, this is meant as a resource for both the team. Yes, we can hear you now. Perfect. Thank you so much. Awesome. So, just like the game manual, there are going to be scheduled updates to the Guide to Judging. Excellent. Okay, got a couple of confirmations. So there is one scheduled for August. That one got a little delayed just because there's some questions about single team or single member teams and how that is handled with respect to the rubric. That should be coming out relatively shortly. And then I believe there was one in December and then another one in April prior to the World Championship. So make sure you're keeping up to date with game manual updates as well as updates to the Guide to Judging. But generally, the overall principles are going to apply through the entire season. So don't expect like a major revision to the Guide to Judging mid-season. Now, in terms of doing well with the judges, one of the things you want to keep in mind is the experience of the judges that you are going to be interacting with are going to vary a lot from event to event. You may have one event where you're working with a lot of judges who have engineering industry experience, former alumni of the program. You have maybe parents that were recruited the night before because the event didn't quite have enough judges, so they're not 100% sure how to do things. All judges go through a training process with a judge advisor, and ultimately anyone can judge. Prior robotics experience is obviously preferred, but it's not a requirement. So you're going to get a vast array of perspectives in terms of the judges you get. And you want to make sure that you're tailoring what you're doing in both your interview and in your notebook for all of those audiences. And we'll go into particulars a bit later. But the number one principle that I kind of go with for everything related to judging is do your best and never give an opportunity for the but moment. What do I mean by that? Well, let's say we're in the judging room. Well, we wouldn't personally be, only the judges are in the judging room. And the judges are deliberating who should win, let's just say the Excellence Award. And there's the top two candidates, and they're trying to reach a consensus. And someone goes, well, team XYZ is great, but we want to try and eliminate any chance that there is a but moment with your team with regards to judging. And a big part of that is making sure that you are nailing the rubric, which we will go over. Speaking of the rubric, there it is, right there in front of you. If you do all of this, you're going to have an excellent shot at winning a judged award. It's all right there in front of you. There are a lot of teams that don't even look at this and wonder why they don't win judged awards. This is why. Are you meeting these rubric criteria? Okay. So let's go ahead and go over the judging process. So that way we understand what a typical day looks like for the judges. So you understand their perspective. So how you can best tailor what you are doing to ultimately win an award. Now, I'm more specifically going to talk about the context of having in-person interviews and in-person notebook submission, since that's the format we typically use here in Arizona. We're going to be having the Arizona Event Partner Summit in a few weeks to kind of reach consensus on that. But generally speaking, that's what has historically been done. That being said,
There are other formats that are outlined in the guide to judging, like submitting your notebooks digitally, doing remote interviews, and the same principles are going to apply no matter what. So you're just going to take what you're doing and you're going to apply it to that format. You're ultimately doing the same thing. It's just the format in which you are presenting that information. So don't worry too much about the particulars there. And you can always read the guide to judging for more details on that portion. So here's what a typical day is going to look like for the judges. They're all going to gather in the judges' room. They're going to be split into pairs, typically 2 to 3 people, depending on how many people have been recruited. And pair or notebooks are going to be given to the judges' pairs, and the judges are going to start sorting those notebooks. And they're going to put them initially into one of 2 categories. This is the first filter you need to get past. Is your notebook a developing notebook, or is it a fully developed notebook? And a developing notebook are the notebooks that are 10 pages. There's barely any diagrams. They're kind of just like thrown together the night before. If you were looking at the rubric, there's a lot of emerging, a lot of proficient. And it's usually going to be pretty obvious just at a glance. So this isn't an in-depth review. This is just I'm opening up the notebook, I'm going through it, and there's not much detail. Not a lot of effort has been put into this. So if you've put even like a moderate amount of effort into your notebook, you're probably going to get fully developed. This is purely just for the notebooks that haven't had much put into them, where they're going to be set aside. Once the judges categorize those 2 notebooks of developing and fully developed, they are going to, in depth, using the rubric, evaluate the fully developed notebook. So they're going to actually go through your notebooks in depth with a rubric side by side next to your notebook and evaluating it point by point to see how well your engineering notebook follows the rubric. The guide to judging says that approximately 30% of the developed notebooks will be considered for Design Excellence Award. That's generally my sense of it as well. When you get to some place like the state championship, this can oftentimes be higher just because, at least for the Arizona teams, y'all are getting really, really good at notebooking. And so keep up the good work there. But generally speaking, this is where you're going to be applying the next filter. So the first was, okay, these are the notebooks that haven't had much effort. Next filter is, okay, these are really the exceptional notebooks that we really want to maybe consider for Design and Excellence Award. And at most Arizona events, your judged awards are going to be the Excellence Award, the Design Award, and the Judges Award. For an event like the state championship, that's where you're going to see a more expanded set of awards. So that's why when I'm talking about winning a judged award, I'm typically speaking in the context of winning the Excellence or Design Award, just because those are part of the standard trophy kit, and that's what you're going to be seeing at qualifying events. But know that all of these principles apply to basically everything. So if you're trying to win the Excellence Award, you will naturally be you will naturally be successful in other areas where you could potentially win other awards as well. Okay. So after the judges have reviewed your notebooks, those same pairs, so let's say I had team 1, 2, 3, 4, and I reviewed their notebook, I will then go out and interview team 1, 2, 3, 4 to actually speak with them in person. The judges guide also lays out an alternative format where one set of judges are only reviewing the notebooks, one set of judges are only one set of judges are only doing the interviews. A tournament might use either method. I know in Arizona, we typically tend to use the same set of judges review the notebook, and then they also conduct the interview for those same teams. So that way they get the full story of the team, and that way it's not disjointed. That's not to say that either method is better. That's just the method that we typically do here, and we find it preferable. But the having dedicated notebook judges, having dedicated interview judges is helpful for larger events. So during this time, when the judges are interviewing you, they're going to be taking notes on a clipboard, usually with, again, the rubric right there. They're going to be referencing it, and they're going to be making notes based off that rubric. After the judges are done interviewing all of the teams that they need to interview, they're going to go back and they're going to deliberate. So the judges are then going to nominate the teams that they want to win each award. So let's say I'm part of a judging pair and I've got a couple of teams that I think would be good candidates for the Excellence Award. I would nominate both of them. Another pair of judges may nominate 1 or 2. You may have another pair that says, you know what, we actually just had a lot of first year teams and they did a great job. We might want to consider them for the Judges Award, but not necessarily the Excellence Award. So not everyone's necessarily going to have an even number of teams that they nominate, but that's part of the judging process. So during the deliberations, this is where the judges are going to begin speaking to one another about the teams that they interviewed and read their notebooks for. And this is where you're going to start seeing the standards of how notebooks were evaluated kind of merge together. Because before, depending on the judging pair, the judges are going to have different levels of experience, as I stated before. So let's say you have someone like me that's in the judging room. I've done robotics before. I have a pretty good idea of what is considered a quality notebook, what is not. I tend to grade a bit more harshly because I know what to be looking for versus someone who's new to robotics. They might be going like, this all seems good. And they might give like a perfect on everything. But then once we all come together as a judging group and we deliberate, oh, hey, we weren't actually evaluating on the same standards. I see now that I should have been grading it like XYZ. And the judge advisor is here to guide the judges through this entire process. They are a qualified, certified person in the room who knows the judging process inside out, who's able to guide the judges in terms of how they should be reaching a consensus. So they're not just blindly doing this. And all the judges have ideally read the guide to judging as well in an ideal world. At the state championship, that's true. But anyway, so where was I? Yes. So as the judges are deliberating, notebooks are going to frequently get referenced during this time. So oftentimes, like I really like, let's say I'm advocating for one of the teams I interview. Like, oh, I really like team 1, 2, 3, 4 because they've got this in their notebook. They talked about it in their interview, and I can pull up the notebook and show the other judges, like, hey, look at this thing that this team did. Isn't it really cool? So this is why, and I'll expand about on more on this in the future. Your number one goal during your judges interview is to be an advocate, or is to make the judges that are interviewing you your advocates, because ultimately the ability for you to win a judged award is entirely dependent on the judges that talk to you to vouch for you in the judging room. So if the judges walk away from interviewing you and they have a really good impression of you and they really like you, they're going to go back to the judging room and they're going to fight for you. They're going to be like, yeah, 1, 2, 3, 4 needs to win the excellence award, hands down. We need to make this happen. And they'll debate the other judges like, no, 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 no. I don't want that. That's an excellent team, but I'm telling you, 1, 2, 3, 4. I'm like randomly praising this 1, 2, 3, 4 just because of sequential numbers, and if that's an actual team number, that'd be hilarious. Anyway, so that's part of your goal during the judging interviews to get the judges on your side. So if there's like, let's say there's 2 or 3 top candidates for the excellence award, very very common thing to happen, and maybe we're not able to get to a clear consensus immediately. What will happen is that a different judging pair will go interview different teams for their follow-up interviews. So if we have the top 3 teams, let's just say for the excellence award as an example, let's say I didn't interview team 4, 5, 6. I'll go talk to 4, 5, 6 while another judging pair will go talk to 1, 2, 3, 4, just so we get firsthand experience with both of them. So if you get a follow-up interview, know that you are being highly considered for an award. So not that you weren't trying before, you were given your A+ game. Now give your A++ game because you might be getting an award. After the teams do their follow-up interviews, they'll come back. They'll usually at that point have a decision of, okay, we've talked to this team firsthand. We now get a better sense of them. I think they should win this award and that award and so on and so forth. For an award like the Excellence Award, there is certain criteria in terms of how high you have to be ranked. So the judges usually at this point, qualification matches are over, skills are over. So they're able to check the final rankings to make sure that, hey, if we pick team 4, 5, 6 to win the Excellence Award, that they are ranked high enough to indeed win it. And if they aren't ranked high enough, we have to go to our second choice team or our third choice team, assuming they still meet the criteria for the Excellence Award. The Excellence Award does not have to be given out at an event if a team does not meet the criteria for it. So just keep that in mind. But generally speaking, I don't think I've ever seen an event where that has actually happened. I'm sure it has somewhere, but it's exceptionally rare just because there's usually at least one team is quite excellent. And then in terms of the selection process for the awards that are done, because the Excellence Award is the all-around most well-rounded team, the judges are going to pick that first because you'll see that team nominated for basically every single award. And it's like, okay, clearly this team is the best. We'll give them the Excellence Award. And then you go down to the Design Award, Innovate, and then it depends on what event or what awards you have at that point from there, depending on a number of factors, which are all outlined in the guide to judging. So just know the Excellence Award picked first, you go down from there. And then just to kind of summarize, in terms of your winning a judged award, there's 5 key areas. Do not underestimate following the REC Foundation's Code of Conduct and student-centered policy. If you are not following the REC Foundation's Code of Conduct, the judges will find out about it and they will heavily weigh it in their decision. I have seen it happen before. So do keep in mind. And also, just the REC Foundation's Code of Conduct is just pretty common sense. Don't be a jerk. Just be nice out there and you'll be absolutely fine. And then obviously just making sure that you have a student-centered policy on your team. It's part of the program as well. Like I said before, it's valuable that the REC has this. So that way students are the ones doing the work and they get this, they really get the most out of this program by being the ones who are driving everything here. And then obviously making sure you got a good engineering notebook, you got a good interview performance. And then if you're gunning for the excellence award, and even just awards that don't necessarily require good competition performance, having a good competition performance and skills performance makes it much easier to win an award. It goes back to the but principle. If you're having a deliberation and you say, well, team A is ranked second in the competition and team D is ranked 42nd, that might be used against you. It depends on the context of the award again, but you never want to give the judges that but moment. Always try to do your best in every category, and that will drastically increase your likelihood of winning. Okay, I will pause for questions real quick. So that's kind of a quick overview of the judging process. Next, we'll go over the engineering notebook. But does anyone have any questions about the procedure in terms of how the judges actually do things? I'll go ahead and set a timer again. This 1 minute delay is quite brutal. Okay, about 20 more seconds here. And I guess I'll go ahead and mention it now. I'll mention it at the end of the presentation as well. We're going to go ahead and restart the main stream at the end of this presentation during the lunch break. So that way we can reduce this latency down, because right now it's a minute. It's fairly brutal. Um, just to give you a heads up. Okay. If I see questions come in, I'll go ahead and pause to address them. But otherwise, I'll go ahead and move on to make sure I'm unmuted. Okay, I am unmuted. Okay, cool. And then I'll check here. Excellent. Okay. All right, moving on to the engineering notebook. So here comes the fun part. So the engineering notebook is ultimately how you're going to document your team's journey through the engineering design process. Now, there are many ways I have seen the engineering design process defined, and there's 4 diagrams below to give you an idea of how many ways you can phrase this. But I would say in the most general sense, the engineering design process is an iterative process that starts with defining a problem, brainstorming solutions to that problem, evaluating a potential solution, and repeating. You can break it down further from there, but generally speaking, that's what's going to be happening. And that's kind of the most recent example in the guide to judging. You can see this third graphic here where it has the 3 circles where it says define, develop solutions, and optimize. That's from the most current guide to judging. So that's kind of what I would base things off of. So ultimately, wherever you are in your engineering notebook, you should make it very clear at what stage in the engineering design process you are currently at. And if your team is going to use like more specific steps in the engineering design process, just make sure you lay that out towards the start of your notebook when you're talking about the project management portion of, hey, we're in this stage of our development, and clearly outline that from the start at the start of every entry. We'll get more into that when we're going over the rubric itself. Oh, and just another random note, most awards are going to require the submission of an engineering notebook. Not all of them, but it's for a lot of them, it is required. And as I mentioned before, during the deliberation process, even if you're up for an award that doesn't require a notebook, it's super helpful for the judges to have your notebook right there and they can point and say, hey, I really liked this part about this team and read these entries about how they developed this particular mechanism or whatever. So it's another way that the judges can advocate for you with that notebook present in hand. Okay, next question. You have a couple of options here in terms of the format of your notebook. You can go digital or you can go handwritten. This used to be a bit more of a debate because Vex or the REC Foundation used to say that, and this is I want to be clear, this is a previous policy. This is not the current policy that it had to be a handwritten notebook, and if you did a digital one, there was a 5-point bonus that you got, so it effectively made it required. That is no longer the case. Now you can either have an entirely digital notebook, or you can still have a handwritten notebook if you wish to. In terms of what is better, I am of the opinion, and again, do what is best for your team. Maybe you don't have the resources to do a digital notebook. I would highly recommend, if possible, to do a digital notebook. The reason for this is it can't be lost. There's always going to be a cloud backup of it, or maybe some digital record of it somewhere. It has increased accessibility. A lot of teams are typically using Google Drive to do their digital notebook. So that way, multiple people can be making entries on it at the same time. So one person is testing a prototype over here while the other person is making an entry about their strategy. So you can have multiple folks working on it instead of you trying to do a weird yoga pose of two people writing in a handwritten notebook at the same time. That'd be quite strange. Another big one, no bad handwriting. There is a lot of bad handwriting I have seen in notebooks, and it's sloppy, to be frank. And it's really, if it's hard to read what you've written, that's not great optics. Again, you never want to give the judges a reason to say but. Like, oh, like I think they've got the material here, but it's really hard to read their handwriting. That eliminates that entirely. Also, you get spell check. Oh yeah, we all love spell check, but we don't like autocorrect because autocorrect will change us to strange words. Okay, and then it's also much easier to include media like snippets of your code, pictures of what you've been working on, or just like pictures of maybe a CAD that you've got, as opposed to having the, print a picture out, cut it, paste it, whole 9 yards there. So I personally highly recommend digital notebooks. The only downside to them is if you have in person submissions, you're going to have to print it out, which is a lot of paper and ink, but I personally think it's worth it. Once you've printed out the bulk of it once before your first tournament, you're ultimately just printing out um, the new pages, so that way you're just keeping up with it. And again, if for whatever reason it gets lost, you can just very easily print out a new one. It's not the end of the world. Also, for events like the World Championship, where you're going to be submitting your notebook digitally, you've got it ready to go. You don't have to go and hand scan every single page in your notebook. Back when I was the coach of Phoenix Lights, they had to do that during the change-up season. That was brutal. So it's I just personally I love digital notebooks. In terms of a template you can just use a blank Google Docs template. Just make sure you're following the formatting requirements that are clearly outlined in the guide to judging and the rubric. We'll go over those briefly. Just make sure you're referencing those. There is a template provided by Vex at notebooks.vex.com. It's a Google Slides template, so you can just they've got nice diagrams of the current game, various Vex parts, so that way you can kind of like show diagrams and put things together much more easily. So that's a nice resource for you if you want to try that out. Okay, in terms of writing your engineering notebook, kind of goes without saying because I've been mentioning it a few times, but you want to write your notebook with the rubric in mind and also for your target audience. The rubric is ultimately how your notebook's going to get evaluated. So if you just write some random story about how my robot went to Candyland and it was wonderful, fantastic. Does it meet your rubric requirements? Probably not, unless it's a very weird game and we have a Candyland game next year. So and then also keep in mind that your demographic or not your the people that are going to be reading your notebook is going to vary quite a bit. So um, if you have someone who's newer to robotics, making sure that when you're writing your notebook entries, you are both clearly and concisely explaining something while still giving technical details to someone who is more knowledgeable. So explaining things in a maybe more introductory way to start, but then really getting into the details for people who really know their stuff to be like, oh yeah, look at all this data that they've got. I love how they can talk about PID loops here, so on and so forth. Also, don't slack on the frequency in which you record entries and also the quality itself. There have been a number of notebooks where the notebooks are 10 out of 10 amazing, and then just they'll drop off for a month, and then all of a sudden the robot is like, well, it's a month later in its development. It's very different looking. And that shows a lack of rigor on your team's part. And there's a couple of points in the rubric that talk about how you're fully documenting everything. It's important that you aren't slacking on the frequency of your notebook. First impressions are also vital in your notebook. The judges are going to open up your notebook and they're going to read your game breakdown. So it should be the first thing in your notebook after you talk about your goals. And so making sure you make a great first impression of clean diagrams, excellent analysis of what you're doing. You want to make an awesome first impression because a lot of the first few points on the notebook rubric are related to how you break down the game. So put your best foot forward and then keep it forward. So now we're going to go ahead and go through the rubric just point by point and kind of give various tips about how to best address each one of these points on the rubric. So the first portion of the rubric specifically covers the engineering design process. And I'm going to cover it in a couple different contexts. The first one is that first impression. So how do you talk about your game breakdown? Because that's the very first time the engineering design process cycle begins. And then I'll also talk about it more generally because, again, it's iterative. So you're going to be going through the engineering design process over and over and over and over again. Anytime you're trying to figure out a problem related to your code, going through the engineering design process. Anytime you're fixing a problem on your robot, going through the engineering design process. And so you're going to be doing this over and over and over and over and over again. Okay, so I'm going to go ahead and read out the rubric first, and then we'll go into details. So the first point, identify the problem. Identifies the game and robot design challenges in detail at the start of each design process cycle with words and pictures. States the goals for accomplishing the challenge. Now, whenever you're reading the rubric, it's important to identify the difference in expert and proficient. So here, proficient says identifies the challenge at the start of each design cycle, lacking in lacking details in words, pictures, or goals. So if you aren't including enough diagrams, if you're not specifically stating what your goal is for the season and pictures to go along with it, you may be labeled proficient rather than expert. Basically, how at least every single notebook that I worked on, how basically every single notebook would start was today was our first meeting. We as a team decided our goal for the season is we're going to, let's say, win our division at Worlds. And then here's how this year's challenge is VRC over under. So notice how it says states the goals for accomplishing the challenge. So the very first challenge you're going to be addressing is the game of over under. So you want to discuss your team's goals and everything we talked about in the first presentation with breaking down the game, documenting that entire process in detail. In terms of including images, it's great to include pictures of the game. If you're doing a digital notebook, you can just like copy and paste, maybe put some labels on it, like here we've got the goal, here's a tri-ball. It's nice to maybe put a dimensioned piece of the tri-ball in, just to put visual information for the judge to look at. And don't just put fluff. Make sure it's meaningful to what you're actually talking about in the discussion. But this goes back to just making an excellent first impression on the judges. If they open it up and they see this really pretty notebook with really nice text and it's got nice labeled diagrams all over the place, just the human nature is going to be much more inclined to be like, oh, I like this notebook. If they open it up and it's sloppy and messy and there's stuff all over the place, there is an element of messiness with notebooks, and we'll cover that at one point. But you generally want it to look as clean as humanly possible. Okay. Now, more generally speaking, when you've moved past the game analysis stage, moving on to prototypes and everything, make sure you are clearly stating what the problem you're trying to solve is at the start of every single new design cycle. Like I said before, this could be a design problem. This could be, hey, something broke on the robot. How do we make sure this doesn't happen in the future? Make sure you're very specifically stating this is the problem and move from there. Okay, moving on to brainstorm, diagram, or prototype solutions. List 3 or more possible solutions to the challenge with labeled diagrams. Citations provided for ideas that came from outside sources, such as online videos or other teams. So, speaking first to the start of the season, when it says list 3 more possible solutions, guess what? If you're going through that game analysis breakdown like we did at the start, you're going to have way more than 3. And generally speaking, whenever I'm looking at a rubric, I'm not looking at the minimum. I'm looking at, okay, what's going to give me a perfect score? How do I do more than that? So that it's abundantly clear. Hey, I definitely have at least 3 here. In fact, I've got 20. Maybe that'd be excessive, but you get my idea. Always try to be exceptional, not doing the bare minimum. Again, it's that but moment of, oh, well, this team has 3, but this other team has 20. Again, and there comes a point where it's a bit excessive, but I hope you get my point there. So in terms of listing possible solutions, so that's ways to approach the game when you're specifically talking about the various mechanisms. These are the types of mechanisms and robots that are going to play the game. And then for later problems, just like you were for the game analysis breakdown, always make sure you're brainstorming at least 3 ideas. If you are truly as a team gathering together and you are truly brainstorming, and by brainstorming, again, I mean you're not rejecting ideas, you're just getting ideas out on the paper, getting at least 3 ideas should be fairly simple and trivial to do. And then you can bring in outside sources from there. And the only difference between these 2 points in the rubric is that one says you've done at least 3, and the other one says you've done 1 or 2. So pretty cut and dry here. And of course, you will get ideas from outside sources. It would be foolish to think that anyone's idea was completely original on their own, so please do cite properly. Okay, moving on to selecting the best solution and plan. Let me take a quick drink of water. So, it states, explains why the solution was selected through testing and or a decision matrix, fully describes the plan to implement the solution. So going back to before of how we use the decision matrix to decide what prototypes we wanted to build, you can use that same decision matrix to decide the success of a different prototype you make or the robot you built. It also says a testing or through testing, so very clearly defining, and this relates to other points in the rubric that talk about testing things as well. Very clearly defining what is my testing process, what are the steps I'm going to do to evaluate this particular problem and solution, and how do I interpret the results of the data. In terms of how you do this with the beginning of the game, you're going to explain why the initial approach was selected. And again, if you recall, this was based off your team's resources, the result of your game breakdown, and how the prototypes informed what your team can build. And then you also want to clearly state what your plan is going forward. So great, you did all this, you based off the testing results, we selected this solution for reasons XYZ. What's going on from what do we do going forward? So one great way to communicate deadlines and just general project management flow is using a Gantt chart. I believe I have one on the next slide. Yes. Oh, no, I'm sorry. That's a decision matrix again. I meant to put, well, I think I have a Gantt chart on a future slide. But using a Gantt chart or even just a simple calendar of boom, copy paste calendar in, here's our deadlines. That's a great visual aid to show when items are going to be due and when you plan on finishing things. Okay. Yeah, just include any decision matrices or testing results for all the decisions you make. If you can provide data for everything you're doing, not only is that great for just legitimately informing your team's decisions, it's also great that it's being documented and it's being presented to the judges. And we went through a decision matrix earlier, so this is just another example. Okay, the next 4 I'm going to kind of lump together because they're all really hitting on the same thing, and that's document, document, document. Documenting absolutely everything. If you look at the differences between expert and proficient here, it's pretty much all, yeah, they either didn't go into enough detail or there's a severe gap in entries here where it's clear they did not record the entire engineering design process. So again, if you got like a month-long break in between entries and all of a sudden your robot went from okay to super, clearly work happened, but you didn't document it. Or maybe you just like threw in an entry and it's like 2 sentences like, today I worked on the intake. It works now. Well, that's not thorough enough. So make sure you're being diligent about keeping your notebook up to date and well maintained. One great way to do this is just take pictures of everything you're working on during a meeting. That way, even if you can't necessarily write an entry on that particular day, your next meeting, you'd be like, hey, last meeting we worked on XYZ. Here's the testing results of this, so on and so forth. So that way you don't forget what you worked on. It's like, okay, I've clearly got pictures showing everything. And then you can also include those pictures in your notebook. Right. Okay, so we kind of covered everything there. So you always, like I mentioned before, you always want to clearly to state what phase of the design process you are in every single entry. So are you in the identifying the problem phase? Are you in the brainstorming solution phase? Are you in the testing and evaluation phase? That is where a lot you want to make it abundantly clear where you are. I know a lot of teams color code what phase of the design process they're in, so that way it's just right up front. Because if all of these points again are just related to documentation where you are, and all these combined, that's a lot of points. Okay, one of the newer points in the rubric for this season, and I love, 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 love this, is innovation slash originality. So, teams show evidence of independent inquiry from the beginning stages of their design process. So, that's speaking generally, but again, like I said, I'll address this in two ways. First, from the initial breakdown, and then more generally speaking for the rest of the notebook. For your initial game breakdown, if you are truly breaking down the game solely in the context of just independent actions, that will naturally lead to original conclusions on your own before you start bringing in outside ideas. And that's why the first step, generally speaking, now, whenever you're trying to evaluate a problem, first things first is to gather your team, try to brainstorm ideas without having looked at any outside sources. Getting outside sources and researching is still very valuable, but by trying to solve the problem on your own first, it's really going to help in terms of not only satisfying this requirement, but also coming up with some really cool, unique robot idea. Just blindly copy and pasting means you're never really going to be better than the people. You might just like match up. But if you think of that innovative game breaking idea and all of a sudden you've just won the state championship or maybe even world championship because of some crazy idea you had, good on you. Um, I love this. So and again, the difference here, teams show evidence of some of independent inquiry for some elements of the design process. So this is just going back to consistency. Make sure throughout your entire design process, you're always making sure you're trying to solve the problem yourself first, coming up with your own original ideas, then branching out to seeing what existing solutions are actually out there. Okay, formatting. So this is a black and white where if you meet this requirement or you don't. And this is further expanded on in the guide to judging. There's a full page that lists everything that you should have in your notebook, but it's concisely listed here. 5 points of the notebook has evidence that documentation was done in sequence with the design process, so you're not going back and changing things retroactively. That should be the big no-no. This can take the form of dated entries with the names of contributing students included in an overall system of organization. For example, numbered pages in a table of contents with entries organized for future reference. So again, the guide to judging includes specific examples like having a table of contents is a must. Having an introduction of your individual team members is an excellent thing to include. And making sure you're dating all your entries, including all of that. And it's best to establish these practices before you start writing anything. So that way it's consistent throughout the entire season. That's not to say if you find a better way to do something, you can't switch mid season. But if you can establish it before and be consistent, that would be ideal, especially if it's a major change. Um, and so information should be easy to find for the judges. The reason for that is that this is going back to advocating for the yourself in the judging room with your notebook. So let's say there's a question about whether or not you really were original enough, right? And there's a really cool, unique mechanism on your robot, but some judge's like, I don't think they necessarily built that on their own. And you can say, oh, hold up. The judge goes to your table of contents. They see where you first came up with the idea. They flip to that page. They say, hey, here's how they got to that conclusion. They they listed XYZ potential solutions, they evaluate them, and they arrived at this design. And then the other judge goes, okay, cool, fair enough. And then you're able to resolve that problem, and you've won the excellence award. Confetti is everywhere, and everything's fantastic. Um, so just making things easy to find for your judges is excellent there. Mentioned it before, but visual aids as much as possible. Make your notebook pretty to look at. Don't just put random pictures in. Make sure they're meaningful and are actually relevant. But if your notebook's nice to look at, your judges are going to look at it. Let's see. Another big one for me personally is this is more so part of the interview rubric. However, I am of the opinion that everyone should be writing in the notebook. And that is because it more clearly demonstrates that everyone is involved in the team. Everyone is contributing something. I know it's common for some teams that maybe have one or two people do the notebook exclusively. That does work. But if at all possible, try to have multiple members contributing to the notebook to show that everyone is actively involved. It gives you a paper trail of, yeah, team member A did a bunch of entries this day. Team member B did a bunch of entries this day, or they're doing entries toward their particular area of expertise. That way, it's abundantly clear. Everyone's contributing. There isn't any question. Again, we want to reduce that but moment. Oh, yeah, that seems great. But only one person wrote their notebook, which again, there isn't anything that specifically states that that's against the rules or would dock you points. I want to make that abundantly clear. I think it's just a good practice as well because doing the notebook, if you're trying to do it properly, is a lot of work for one person. Okay. So moving on to actually evaluating your notebook. So for a number of reasons that are complicated, you will unfortunately not receive feedback from judges at events about your notebook. So it's important that your team has the ability to evaluate it on your own. And there's a few ways you can do this. You can, as honestly as best you can, you are a biased party here, but try to evaluate your notebook as honestly you can. Rubric side by side your notebook and evaluate it just as you would as if you were a judge. Um, you're obviously going to know exactly where everything is listed. Like, oh, I know that I've listed 3 solutions for this thing here and on page such and such. That's why it's helpful to sometimes bring some outside help in. So if you have friends, family, teachers, maybe you know some folks in industry who are engineers, just hand them your notebook. Be like, hey, obviously, well, they'll just hand it to them. Be like, have fun with it. Ask them, hey, would you mind evaluating my engineering notebook? I want to see how well we're meeting the requirements of the rubric. And obviously, give them background if they don't know what exactly they're doing, but have them honestly assess it so that way you can find your weak points and correct them quickly. Another important note is that you cannot go back and change your notebook, but you can always improve your future submissions. As a judge, if I saw a team that maybe was a little lackluster at the start, and the only exception here is that you really do need your game breakdown and initial first impression to be solid 10 out of 10 material. It's hard to come back from that just because so many points in the rubric are talking about that initial game challenge and doing well. Again, it's more broadly also talking about. Oh, we do have a question. I will get to that in a minute since that is a rules question. Um, Yes, I see your question. I'll answer that in 1 minute. Um, Lost my train of thought there. Ouch. I think I was mostly done with my thought there, so I think you get the idea. Have other people evaluate your notebook, and don't have other people, or don't go back and change entries. And then also just make the notebook your own. Make sure that it has your own sense of character. You know, how if you want to color code things, what colors are you going to be picking? Just make sure they're clear and legible for the judges to read. Maybe you've thought of your own unique way to present data that's not presently out there. Just anything that helps distinguish your notebook. Um, just anything that helps with that. Because if you give a reason for the judges to go, oh, there's this team's notebook and it's got this really unique thing about it. Give reasons for you to stand out. Okay, pause for questions. I'll go ahead and answer that right now. Are we allowed to place match loads on the robot if it's in the match loading zone? So if by in, so we'll just pause for a brief rules question. I'm pretty sure the answer is yes, but I will pull up the game manual just to be absolutely certain. I've read through it like 3 times now, but I have not actually refed an event yet, so it's not like concrete in my mind. Match loads. It's interesting. If it is in the match loading zone, I'm like 99% certain the answer to this is yes, but I just want to be absolutely certain before I speak with certainty. Match load zone. Original bar. I think it's what SG6 that talks about this. And again, feel free to put your judging questions in. I was naturally going to pause anyway, so this is kind of just a nice little break. Yeah, so I would point to SG6 here. It says match load triballs can be safely introduced during the match under certain conditions. For the purpose of this rule, introduce refers to the moment a match load triball is no longer in contact with a human, and it has crossed the plane of the field perimeter. So, where's the exact verbiage here? Yeah, so SG62A is going to be your rule there. So that's by placing a match load gently onto a robot from the Drive Team Members Alliance, the robot must be contacting the match load zone or the match load zone bar. So yes, the answer is yes there. Okay, any questions about judging? Or just other rules questions, I suppose. I don't want this to turn too much into ask head ref questions because ultimately we're here for the notebook. But since I have that minute long delay, might as well. Okay, if I see another question, I'll go ahead and go back to it. But for now, we'll go ahead and move on. Okay, so now we're going to go ahead and move on to the judges' interview tips. So, as I mentioned before, your number one goal in the team interview is to make the judges your advocates. You want them to go back to the judges' room fired up, being like, they got to win this award, hands down. So, you want to make a great impression on them. This obviously means you do need to make sure you're checking the boxes on the rubric. You can't just be like super charismatic and then win. Oh, we got a question. What are some good places to learn about robot designs? Because I am new to Vex and will be competing this year and I would like some help. Yeah, absolutely. So just kind of go back. So our first presentation, and that recording will be available a bit later, that has some resources in terms of, I would recommend building the Hero Bot. There is there's resources on the REC Foundation website, the knowledge base articles. There's also a build tips robot or build tips presentation happening this afternoon. That's going to take place at I think 1 or 1:15. So that's going to be an excellent resource for learning specifics of how to build a robot. And if you have any other questions, let me know about that. I'll go back to this though. Okay. Um, yes. So number one goal, make the judges your advocates. You do want to make sure that you are checking the boxes on the rubric because ultimately, if you're not getting perfects on the rubric, although the rubric is not the end all be all, because again, judges are going to evaluate the how difficult they are with the rubric differently, and so they're going to come together and reach consensus on things. So it's important for you to try and be as exceptional as possible so that you don't create any doubt. The other important thing, though, is that interviews are an exercise in charisma. So you do want to make sure that you are excellent at presenting as well. So, standing up straight, being at attention, making eye contact, smiling, speaking clearly and slowly, making sure your pit area is nice and organized. If you've got a messy table, that's not to say that you're going to get dinged for it. But again, you want to look as professional as possible and really show that you guys know your stuff. And kind of similar to that, you might be wondering, well, should I be practicing my judges interviews then? The answer is you can. And I would, if you're a newer team, I would recommend practicing a little bit. There are some sample questions in the guide to judging that you can find, and you will find that judges will sometimes use those questions. However, the judge's interview is a dialogue. It's meant to be an open discussion with open ended questions. So you do not want to have a presentation or a script that you jump into. It should ultimately be a natural conversation that you're having. And you shouldn't be trying to pigeonhole yourself into, okay, I'm trying to get the judge to get to this certain talking point that I want to talk about. So I can get on my script here. Ultimately, is a dialogue. And when you're being interviewed by the judges, just keep a mental checklist in your mind of the point of the rubric that you've addressed and the point that you haven't. Usually, what we did in our team is everyone was responsible for a certain part of the robot and also had to keep in mind what parts of the rubric they were addressing. And this is where you need to try to hand off talking to each one of your team members. And this is more or less difficult depending on how many team members you have. In an ideal world, you do not want to have the judges have to prompt maybe a more quiet team member to speak. And we'll go over the exact rubric point in a minute, but everyone should be independently speaking at some point. Sometimes the judges will prompt the more quiet student to speak. Other times they just may expect you to speak up. And this applies to all the points on the rubric. I know some judges' philosophy is you're the ones that are here to talk about your robot. Like, you should know what you're doing. Like, talk to me. And some judges are very, very, ask a lot of questions, are very involved, and are going to be a self advocate for you. So, this is my personal approach. If I notice a team hasn't addressed a certain portion on the interview rubric, I like asking them an open ended question related to that point on the rubric to make sure that they have an opportunity to specifically address that point. But I know some judges like to say, that's your responsibility. You have to figure that out on your own. So, keeping a mental checklist in your mind of what you've addressed, what you have not, very important. Okay, so moving on to the understanding of your robots. I'm sorry, that's the next slide. How your engineering design process works. So this open dialogue that you're having with the judges can see your robot. They've looked at your notebook, or if they haven't personally read it, another set of judges have read your notebook. They know the design you have. They can see it on the field. They can shoot it, see it shooting tri balls, whatever, right? The interview is more so they want to know how the engineering process led you to this particular design. Why do you have this robot design and not some other random design? What are the reasons? What's the journey? It's not the destination, it's about the journey, right? So you want to more clearly focus on how you got to where you are today with this current robot design rather than, oh, this is the robot design, here's all the cool things it does. That will naturally come up, trust me, but your focus should be the process. And I know I said that you don't want to have like a script of what you're doing, but what we would always do in our teams is as soon as we could, we would try to make sure we talk about our game strategy and how that informed our robot design. So we decided this is the best way to play the game for our team, and that informed how our robot was designed because of our team's capability of XYZ. So getting that all out there. And do I have it on the next slide or do I have it? I'll go ahead and mention it here, and if it's somewhere else, that's fine. I don't mind reiterating this point. Another nice thing, or another tip I have with regards to the judge's interview, is trying to reference your notebook as much as possible. The reason why is then you're putting little worms into the judge's brains of, oh, they talked about this really cool thing that they did, and it's also documented in their notebook. So they remember that better. And also, when they go back and they are deliberating with the other judges, and some judge says, blah, 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 blah. I don't know why I'm making the other judges sound antagonistic in this example. They're all very nice, but those judges can go back and say, oh yeah, this team talked about this really cool thing they did, and they said it was in their notebook. Flip through, let me go to their table of contents again, easy to read. Oh yeah, look, right here in their notebook. They talk about it right here. And then everyone goes, wow, very impressive. So just referencing your notebook about how you've documented it and reinforcing that these are one of the same, it makes the judges remember you better. Okay. Another aspect of the interview rubric is just checking for understanding. And this is honestly more so just making sure that you're following the student-centered policy, in all honesty. It's just making sure that the students understand what the robot is and making sure that they're the ones that built it. If you are having an open dialogue with the judges about your robot, it's going to be pretty apparent from the start if the judges or if the students were the ones that actually built, programmed, and designed this thing. If you just say, "Oh yeah, this is our robot. It's cool and it does this thing," and you go, "Well, why does it do that thing? How did you get to that design?" It just does. That's when you're probably going to get docked points. But as long as you're having a open conversation, like, oh yeah, this is our climbing mechanism. Look at these cool little details. Like I've built this little thing. It's got a special locking mechanism, and I found that like this, strength of rubber band wasn't quite good, so I doubled it up here, and just showing that you were the ones that built it and you understand it. That's all that needs to happen. I wouldn't worry too much about this as long as you truly have built the robot. Um, it's going to come up naturally. It's usually pretty easy to address. Okay, project management. So a big part of your notebook, as mentioned before, is the project management aspect of it, and like recording your timelines, like calendars, Gantt charts, setting deadlines for yourself, documenting that all in your notebook. And really, this is a great example of how you can just reference your notebook. I'm like, yeah, we used our notebook to as our primary source for documenting our progress to the engineering design process. It was our primary tool for our project management, and you can find all the deadlines we had in there. And you can also speak generally about it as well. Like, oh yeah, on October whatever 28th or whatever was our first competition, and we had these things to meet. Um, and kind of the difference between expert and proficient here is that proficient is just progress was monitored, but expert is, yeah, we tracked everything against an overall project deadline or timeline, and you can explain all of it. So again, leaving that paper trail in your notebook, excellent way to satisfy this requirement. Okay. This is kind of going back to what I was talking about before in terms of making sure each team member speaks up independently without being prompted. And it's nice to usually have, like I said, everyone's responsible for talking about a different part of the robot. Maybe a couple people are more focused on the game strategy, so they are maybe the ones talking about the initial approach of the season. And one of the things that I would definitely practice on, this is again, not to sound scripted, but knowing how to practice handing off to team members. So after you're done talking about certain part of the robot, like, oh, I worked on the intake mechanism and I worked with such and such to make sure that it was compatible with the shooter, such and such. Why don't you talk about the shooter now that I'm done talking about the intake? Or sometimes a judge will ask like a specific student, like they'll point at a student, they'll be like, tell me about this thing. And maybe that's not the thing, like let's say you're the one being pointed at, and that's not actually the area yet you worked on. A way that you can then because that's like a very intimidating moment that I've seen that happen sometimes. I'm not a huge fan of when judges do that, but it happens sometimes. But let's say you get pointed at and a judge asks you a question about the robot you have nothing, you know nothing about. The way to um, deal with that situation is you can say, actually, I didn't work on that part of the robot. I worked on X, Y, and Z, and I would be happy to talk about that. Such and such worked on this instead, and they would be happy to talk about that if you'd like to address that now. Or I could talk about the areas I worked on, and that's a great way to kind of hand off between members. We got a question in the chat. When will we be talking about building and designing? That will be at 1:15. So in the secondary room, it's the robot build tips presentation. Okay. Although we're making excellent time here. So we've got this is my last slide. So, and then in terms of competition performance, I offhandedly mentioned this before, but if you are trying to win the Excellence Award, as it's currently listed in the guide to judging, is you need to rank in the top 30% of overall skills. New this season, you need to rank in the top 30% in the Autonomous Coding Skills Challenge. I think that's the full name of it. I like programming skills better because it's not as clunky as the Autonomous Coding Skills Challenge, but I don't make the rules. Um, and so you have to make sure that not only are you exceptional in skills, you also have to be exceptional in the Autonomous Coding Skills Challenge. And then also you need to rank in the top 30% of the qualification rankings if you want to win the Excellence Award. Like I said before, even if you're not necessarily trying to win the Excellence Award, I would highly recommend trying. I mean, everyone's trying to rank high, but if one of your team's goals for the season is you do want to win a lot of judged awards, you probably want to have a robot design that's more tailored towards ranking high, maybe rather than a niche robot. That being said, the design award doesn't actually require that you rank high, and that's effectively excellence award second place. I don't want to say that like definitively. There are very much differences between the two awards, but usually excellence award and then whoever was runner up for excellence award tends to get design award. Okay, so I like leaving time for questions. That's why we ended about 15 minutes early. So Oh, I accidentally went to a different tab for the questions. Okay, no one asked a question there. So we've got about 15 minutes here. So I will go ahead. I'm sure y'all have questions about judging. Usually this is a pretty um, in-depth topic. So if there's anything you want me to expand on or clarify, I'd be happy to do that now. I'll just go ahead and put the rubrics on the screen just because that's um, we like the rubrics. But I'll be here for the next little bit, and if I see a question pop up, I'll go ahead and address it. I am here. I'm just going to go ahead and full screen the this rubric until I see a question pop up. Just that way you get a full screen view. Okay, it looks like we got a question. Let me come back here. Okay, where can we find the guide to judging book? Is it on the website? Excellent question. So I'll go ahead and actually drop it in the chat real quick. But if you just Google Vex Guide to Judging, it should just pop up. Pop that in the chat real quick. Oh, did I not do something right? Oh, I can't hit enter. I have to click send. So that's in the YouTube chat for those that want that. We'll give it another 5 minutes or so, and then I'll go ahead and break for lunch if there aren't any more questions. And before folks kind of start pouring out a little bit, in case you are breaking for lunch, as a reminder, we're going to go ahead and end this stream. We are going to restart it, so I'll go ahead and email everyone that's registered with a new link. It's still going to be on 18 by 18AZ's YouTube channel. We just want to try and fix this delay. There's a couple of settings we have to adjust, but we have to end the stream in order to do that. So um, don't fear that this stream is ending. It will be back on 18 by 18AZ's channel. Okay, it doesn't look like we're getting any more questions. Feel free to keep posting them in the onlinequestions.org since the YouTube chat's going to temporarily shut down here. But otherwise, we're going to go ahead and break for lunch, and we will be back with a new link for the main room, second room. That's fine there. So, just as a reminder of what we're going to be going over in the afternoon. So, here in the main room, Charles is going to be going over intro to control and sensors, as well as an intro to programming. In the secondary room, that's where we're going to have our robot building tip. So for those of you that are wondering, how do we build a robot? That's going to be your one-stop shop. So thank you all, everyone. I hope this was useful. And if you need anything, don't hesitate to reach out.